Okay, question of the week, week 18, higher tier questions. These are tough, we may be here sometime. Okay, find the solutions to three significant figures of x plus 1 all squared equals 12. Right, a couple of ways to do this. I'll let you decide which one you think is easiest. Right, number one, we could say x plus 1 squared equals 12. I'll take the square root of both sides. That's going to give me x plus 1 is equal to the square root of 12, but I need to be careful. If you've watched the foundation ones, I need to be careful because that could be plus or minus the square root of 12. Okay, remember that a negative times a negative makes a positive 12, so we can have a plus or minus the root 12. Okay, we could then subtract the 1. It's going to give me x equals. Okay, now we'd normally write negative 1 because I've subtracted 1 from the right hand side, plus or minus the square root of 12. So this really means x is equal to minus 1 plus root 12, or x is equal to, sorry, I should do that here maybe, x is equal to minus 1 minus root 12. It's like two separate equations. Okay, so we can now work both of those things out. Go away. Okay, so calculator paper, so right, we're going to put negative 1 plus root 12 is equal to, thanks calculator, has to do it, 2.464 blah blah blah. Okay, so we want three significant figures. So x is equal to 2 significant, come back, the 4 is significant, the 6 is significant, and we're not going to round up, so 2.46. Okay, so negative 1 plus root 12 gives me that solution. What about x equals negative 1 minus root 12? Let's do that. So we want negative 1 subtract root 12. That's to do. And we get negative 4.464. Alright, so three sig figs, we're going to have negative 4.46. Again, we're not going to round up. So minus 4.46. Okay, and we're done. Those are our two solutions to three significant figures, 2.46 and negative 4.46. Right, I said there was another way. Okay, the other way is we could use the quadratic equation, okay, which involves you knowing that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and this equation can only be used if we've got a quadratic that's equal to 0. So to use this, first of all, we're going to need to say, well, we've got x plus 1 squared equals 12. Let's expand the left-hand side. That's always going to cause you less problems if you remind yourself by writing it out in full. That means that. And then we can see we've got a FOIL or grid method. We've got x squared plus 1x, we're then going to get plus 1x, it's going to give me plus 2x when I've simplified. Plus 1 equals 12. Alright, but remember I can only use my quadratic equation if my quadratic's equal to 0. So I want x squared plus 2x, and we're going to subtract 12 from both sides. Okay, so I've got plus 1 subtract 12, that's minus 11 is equal to 0. So now I can use my quadratic equation. And to use it, I need to know that a represents this coefficient in front of the x squared. And there's no number there, so that means 1x squared. So a equals 1. And b is 2. And c is negative 11. Alright, so I can plug those in. We know that x equals negative b, that's negative 2 plus or minus square root of 2 squared, b squared, 2 squared, which will make 4, subtract 4 times 1 times a negative 11, all over 2a, which is 2. Okay, so let's do some simplifying. We've got x equals negative 2 plus or minus square root of 4 subtract 4 times 1 is 4, times negative 11 is negative 44. So we've got minus minus, oh, careful, 44, all over 2, which is the same as minus 2 plus or minus square root of 4 plus 44, root 48, all over 2. Okay, now if you're good with surds, you might be able to show that that's exactly the same as what I had on the left-hand side. Yeah, what I had on the left-hand side on the top left. Alright, but if not, we could put in both of those solutions. So we've got negative 2. Actually, let's do it as a on the top. We've got negative 2 plus root 48 all over all over 2. Now fingers crossed, that's going to give me one of my solutions from before, which it does. 2.46. And we could then go on to do negative 2 subtract root 48 over 2, which is going to give us our other solution. Okay, both the same answers. Now I certainly know which I think was the easier method. Okay, this one that gave us x equals 2.46 or negative 4.46. Having said that, you do need to know the lovely quadratic equation, so it's something you need to learn. Sometimes you will have to use it, or they'll specify that you need to use it. So learn it. Okay, functions question. The functions f and g are defined below. F of x equals 2x minus 1 and g of x equals ax minus b, where a and b are constants. Alright, so this notation here, f of x, it's really just saying that this is some function of x, this bit here. That set of instructions, it tells you what to do, and it tells you whatever x is, double it, 2 times x, and then subtract 1. And g of x is a different function, it's a different set of instructions. It says whatever x is, multiply it by a, and then subtract b. So f of x is a different function to g of x, they're a different set of instructions. Okay, right, given that g of 2 equals 7, right, what on earth does that mean? Okay, so we know that g of x is the function that says do a lots of x and then subtract b. So g of x equals ax minus b. G of 2 means we substitute 2 in as this value here for x. We put 2 into that value for x. So g of 2, which we could write g of 2, is 2a, because x is now 2, a times 2, that's 2a, subtract b. Okay, so g of 2 equals 2a minus b. And it says here that g of 2 equals 7. So, okay, that means that this is equal to 7. G of 2 is equal to 2a minus b, which equals 7. So 2a minus b must equal 7. So we've got some sort of equation there with a's and b's in. Can't solve for those yet. What else do we know? Okay, we know that f minus 1 of 5. Whoa, what's that all about? Right, this f minus 1 notation is an inverse function of f. And an inverse function just undoes the function. It's like going backwards. Okay, if f of x, which we know is 2x minus 1, f minus 1 of x would be the inverse function of x. It would be the function that undoes the 2x minus 1. It undoes the function x. And you've got to know how to work out inverse functions. So we're going to go through the rules for that now. To work out an inverse function, right, the first thing we're going to do is replace that f of x with a y. And we're going to say y equals 2x minus 1. So we haven't really written that in a very different way. The function of x was 2x minus 1. We're now just representing that with y. Now to find the inverse function of x, here's what we need to do. Now some people substitute the values or swap the values of x and y now. Some people do it at the end. Both methods work out in the same way. So some people swap the x and the y values now. So we're going to change that into x equals 2y minus 1. Okay, so when you've got to this stage, you're going to swap any x's for y's. Swap x is for y's. Alright, so any x's you see will swap for y's, any y's you see will swap for x's. And then we're going to solve for y. Or rearrange for y, I probably should have said. So x equals 2y minus 1. We want to get y equals. So I think if we add 1 to both sides, that's going to give me x plus 1 equals 2y. Okay, so if I divide both sides by 2, that was a plus 1, you can't read. That's made it even worse. Plus 1, that's it. That's a bit better. Okay, we're going to divide this by 2. Alright, that's going to give me x plus 1 all over 2 equals y. Okay, which normally I'd put the other way around. Y equals x plus 1 all over 2. Alright, so y equals x plus 1 over 2. Now the last job is we're going to swap that y for f minus 1 of x. So we're just replacing our notation again. Okay, that y now becomes f minus 1 of x equals x plus 1 over 2. So this thing here, which we found by putting y equals 2x minus 1, then swapping the y's and the x's, then rearranging for y, and then just replacing that y at the end with f minus 1 of x. Okay, this is the inverse function, which we've found by following those rules. Okay, if you need some practice on that, go to your workbooks or come and see me, we'll go through some questions. Alright, now, just before we do anything else, it's worth saying that this f minus 1 of x, right, means the inverse function of x. That's what that f minus 1 means. It does not mean, okay, that f minus 1 of x is 1 over, it's not a reciprocal. It is not something like 1 over 2x minus 1. You might be thinking that, well, if f of x was 2x minus 1, this means the reciprocal of that, 1 over that. It does not mean that. Apologies. Okay, I don't know why I'm apologising, I didn't make it up. Okay, the terminology can be misleading. Right, it's not a reciprocal, it's terminology that means the inverse function. Okay, so we found the inverse function, we found f minus 1 of x, it's x plus 1 over 2. Okay, where were we going with that? We were going, f minus 1 of 5. Right, so f minus 1 of 5 means do what we did before. We know what f minus 1 of x is, let's bung 5 in, we'll substitute 5 in. So we know that's 5 plus 1 over 2. Well, that's easy. That's 6 over 2, which I reckon is 3. So f minus 1 of 5 is equal to 3. Okay, now what? F minus 1 of 5 is equal to g of minus 6. We've got more to do. Let's go for a green. So what's g of minus 6? Well, g of minus 6 means bunging minus 6 into our g function. And our g function, we know, is ax minus b. So g of minus 6 equals ax. But we know ax is now minus 6. So it's a times minus 6, which looks very messy the way I've written it there, subtract b, which is just minus 6a minus b. Okay, so that says a times minus 6, that's messy. Okay, so we've substituted in minus, into the x. We've substituted in minus 6 into the x value. That gives me minus 6a minus b. So g of minus 6 is equal to minus 6a and minus b. But g of minus 6 is equal to f minus 1 of 5. So we know that f minus 1 of 5 is 3. That's here. So 3 is equal to g of minus 6, which is minus 6a minus b. Now, all those minuses on the right we could tidy up by adding 6a, adding b to both sides. That's going to give me 6a plus b equals, subtract 3 will be minus 3, which is a little bit neater. Okay, I'm running out of time. You should convince yourself that those two are the same. Right, we've now got two equations with a's and b's in. Okay, now before you watch video C, right, I would like you to take those two equations, 6a plus b equals negative 3 and 2a minus b equals 7, and solve them as simultaneous equations. Okay, so solve those two simultaneous equations and then watch video C. Good luck.